Good afternoon, everyone. My name is Francesco Petruccione. I'm the interim director of NITheCS, and I welcome you all to the April mini-school. Yeah? And today I'm particularly happy to be able to introduce to you Binjamin Barsch from the Center of High Performance Computing in Cape Town. Binjamin is the lead software engineer at the CHPC. And as you know, CHPC is part of NITheCS, which is part of the CSIR. He studied mechatronic engineering at Stellenbosch University and completed then his master's in engineering degree in radar digital signal processing at UCT. After which I think he worked for various tech software companies until he ended up at his current role at the CHPC, where he's leading the software engineering architecture and the design and development of high-performance computing support software. Yeah. Some of you might know Binjamin from the school that we organized, from the summer school that CHPC and NITheCS organized at the end of January, beginning of February. And you might also be interested to know that his research is on digital signal processing for the Internet of Things and for natural language processing for African languages. And that both sound like two further mini-schools, Binjamin. So Binjamin, we are really happy to have you with us today. You already started sharing your slide. You're most and welcome to start. And sorry, I always forget to encourage the participants to make use of the Q&A to ask questions, and maybe at the end of the webinar you can raise your hand and we can give a few of you the opportunity to ask questions in person. Yeah. So Binjamin, thank you very much. Over to you.
Cool. Thanks so much, Prof. And it's great to be here. Thank you and welcome everyone to this mini school. So as you probably aware that today's mini school is focusing on pandas. So Mastering Pandas, an in-depth guide in data science techniques for researchers. So let's start this. So I quite like this quote, you know, when we speak about mastering pandas, what does this mastering actually mean? So this book by George Leonard, he wrote a book about mastery, specifically using martial arts as his reference. But he defines mastery as a continual journey or the process, and there's no end or perfection of the skill. Rather, it's the practice as a point of itself. So I think that's my goal or the aim of this coding summer school is a journey. Well, for all of us as researchers and ultimately students of knowledge as well, to always be on the journey and try to improve and perfect that skill. So that's where I want to start off. And then just a bit about the agenda for today. So I'll look a bit about myself. So actually, Prof already introduced myself, so I won't look at that much further. A bit of admin items, and I'll look at the mini school overview, what will we cover over the next 4 weeks. We're going to speak about data, because obviously, like pandas, you work with data. We're going to do a quick EDA, just to kind of get our hands wet or feet wet, put it that way, and then discuss Pandas Part 1, right? Just kind of lay the foundation for what we're going to speak about today and the weeks to come, and some useful resources as well, because this shouldn't be your only, well, I'm probably not the only time you're going to be learning pandas. I mean, there are many other resources to use and to continue the journey of learning. All right, so I won't go describe, much about here because Prof already mentioned it. So I'll just carry on to the next item, which is some admin-related aspects. So if you know me from the coding summer school, I try to be as interactive as possible, and I would like to know, the audience that's part of the mini school. So please, I did put a form on the chat, so I put the form there again. So this form, it just asks, name, institute, degree, what tools you use, how familiar you are with pandas, and is there anything specific you'd like to cover. So obviously I have a certain format, but for the coding summer school. But if you can, let me know something maybe interests you specifically, or maybe issues you're having with pandas, I can try to help or try to explain it further. But please fill this in. This gives me a bit of idea of who's part of the yes. So the link is there, Mohammed Hassan. Paste it again. So it is there. Okay. So that is the right. So that is a form. So please, while I'm doing my intro, just fill it in. You can just listen in the meantime. Also importantly, all the code and lessons is on GitHub. So if you go to, if you just go, where's that one over here? So if you go to that link, so we go to lecture 1, you'll see all the code that I have. Is the form? Oh, sorry. I need to speak to everyone. I was sending it to the hosts. Sorry. There is a link. Sorry about that. I was sending it to the hosts and the panelists. There's link here. So there is link again. So here is the my GitHub repo. So I'll post this as well in the chat. If you want to follow on, all the notes for lecture 1 is here. There's a few Python files, a dataset. I'm using the Iris dataset, a Jupyter notebook just for the first part of my presentation, and some other things. But I mean, you don't need it just yet. You also have the slides as well for today is also here. So this is where I'll keep it. Any updates to the notes, I'll just push after lessons. So it's this is how the environment I'll be using. Okay. So that is that. And then, yeah, so I have a few slides, as you'll see, but if you were part of a coding summer school, I try to be interactive. I want this to be a code along environment. So I'll be coding, asking questions and getting feedback. So as much feedback, on the chat as possible will be great. And I'm asking questions too. So again, the plan for today is I have a general idea where it should go, but getting your feedback and answering questions will definitely help. And I'll be using Spider as my IDE, my environment, coding environment. So I mean, you can use whichever environment you want. If you're familiar with Jupyter Notebook, VS Code, whichever one, doesn't make too much of a difference. But just Spider has very nice features for for looking at data and data tables and various other things that the other IDEs don't really support too well. And just importantly, I'm assuming that you have a fairly good understanding of Python and Pandas. So if the concepts, if you're new to Python and Pandas, you might struggle to follow today. Yes, so this is some admin items, and I think that's all I wanted to cover. So please just carry on. Please make sure you fill in the form. We'll be checking that shortly. There's a form again. All right. So what are we going to cover in the next 4 weeks? So today we're going to look a bit about the Pandas data structures. Just cover some of the fundamentals, bit of manipulation and filtering. Aggregation won't cover today. I decided to change it a little bit. Next week, we'll cover it then. Next week, we'll look at aggregation, data wrangling, merging, joining, time series analysis. Following week, let me get my pointer. Following week over here, data visualization, stats modeling, managing varied dataset types. So not just like CSV files and the SQL files or various other Excel files, text files. I mean, you get various types of data files you work with. And then the following week, we'll look at other advanced techniques and some real-world applications. And then generally, I'll be mentioning EDA, exploratory data analysis will be a part of our discussion. Also big data. It won't really be, I'll just highlight a few aspects and probably only discuss it a little bit next week. it is important to consider, because you can do, just to some degree, big data with pandas. Then data pipelines as well, ETL, ELT, and various, how to manage pipelines in the best way when you're working with data. So again, the mini schools aimed at those that are familiar with Python and Pandas, and by the end you should have hopefully picked up some skills or new ways of analyzing your data sets to derive some meaningful insights. All right, so that's the overview I have for today, and gives you some idea of plan for the next few weeks. So, okay, this is a point that doesn't allow me to. Next slide. Okay. So because you are speaking about data, I think it's important to start with looking at different data types. So this site is more like a show and tell site, which I find a very nice to introduce, the topic of data, because it categorizes different types of data very well, and also gives you templates to work with when you're based on your type of data. So for example, if you have over these links, let me just put this in the chat as well. Let me just go back. Put the link here as well so I can follow. So for example, if you have a numeric data, a single numerical value, most likely you're going to do a histogram or some type of density plot. And if you click on here, it'll describe what a histogram is, and then give you 4 different options for code. So we work with Python, so it does give you R as well, and JS and React, but we work with Python. So if you click on Python, it'll give you different or a code snippet, for your single numerical variable, and how to plot it, right? So so this is a very nice site, and just to give you some idea of how to use it. If you have 2 numerical values, I mean, you can give you examples of what that is, or between ordered and not ordered. I mean, this is a science in itself, but it gives you various types of plots you would focus on or use if you have these types of variables. 3 numerical variables, and whatnot. It carries on. Categoric, 1 categoric variable, bar plots, 2 or more Venn diagrams, and all different types. I mean, it's quite vast and very useful. Numerical and categorical, it's many options there. If you're working with maps or geographical data, very nice sites, very nice options it gives you how to use this. Network, so if it's distributed data, some useful examples here. And then time series analysis too, right? So this is just more of a show and tell, just to kind of get our minds, in sync with data and pandas. So very nice site to use, and hopefully you'll find it useful. Okay, so okay, so that's Data2Viz. You can check it out, and maybe you can find something useful. There are some other story, stories behind different data, real world examples as well. You can check out. I'll do the space bar here. Okay, so just to get our feet wet, we're going to look at there's a quick EDA of the RST dataset, which I'm sure most of you are familiar with. It's very popular, very well researched and analyzed. So it's 2 different types of flowers, and then different features and how they're categorized. So I'm going to use this now to start, in Spider, and let's show you a bit about the data and how we analyze it, and a useful tool before we actually get into the fundamentals of pandas. Okay, so while I get my pandas up and running, let's move this over here. So I'll explain what I'm doing shortly. I just want to check on the forms, how the forms are looking. Let's make it bigger. Okay, I have 70 responses so far, so please fill in the form. We have over 160 people. Quite a good distribution of institutes and degrees. So most MSc or PhD and postdoc. I see a majority of people use R. Sorry, most people use Python, some R, and then some MATLAB, some SQL, which is good to see as well. We can cover a bit of SQL too. And then, yeah, so it's interesting, the average rating of people that aren't familiar with Python, which is the average rating out of 10 was 5. Well, actually 4.2. So if you're not familiar with, if you're not familiar with pandas, you might struggle with some of the aspects. There's some looking things you want to cover specifically. Joining row-based operations, filtering, machine learning algorithms. I don't think we're going to have time for that. Data frames, missing data. Okay. Okay, still new. So it seems quite a lot of people are new to pandas, which is going to be interesting. Okay, somebody asked about the form, so please do the form. Yeah, so hopefully my screen is a bit better. You can see what I'm doing there. I'll be monitoring the feedback in the meantime. Okay, so you don't have to worry about this code too much. What I'm doing is I'm taking the iris dataset, which I'll show you shortly, and I'm doing a EDA using a application, well, a library called Profile Report, which I'll discuss a little bit later. And if you're familiar with pandas, you would obviously know about, the describe function, also the describe method, .info. And you have to do quite a bit to kind of get analysis, if you manual like a correlation between the columns and whatnot. So what Profile Report does all that stats analysis for you, and it visualizes it very nicely. So briefly, I won't discuss this code too much. This is going to come later. But I'm reading in from a URL, the iris dataset, specifying the column names. And then what I'm doing is, well, one thing they don't include in a pair plot. They don't have like a pair plot where they compare the columns or features very well. So I just added that extra. And then what I'm doing is running the profile report. So again, you don't have to worry about the code. I'm just briefly explaining it if you're interested. And then I'm developing the report, and it's the report is displayed as on an HTML page. Right. So if I run this, then my profile report is over here. There we go. So this is what it looks like, right? So if you compare this to like pandas.describe, it's like day and night, right? So okay, somebody asked for the GitHub repo again. So yeah, thanks, Abbas. Yeah, okay, he copied it. So this is like an EDA done for you using very nice Python library called Pandas Pro Profiling. I'll discuss it a bit later, how to install it and how to use it. But we're first doing the iris datasets and just getting our feet wet with working with data. Okay. So what does this tell us already? Well, there's 5 variables, 150 observations, no missing cells, duplicate rows, 2 variable types. It's numeric and categorical, right? So if anyone is used to pandas, can you give me a thumbs up that this is way better than .describe or .info or the manual approaches you have to use? You can put a thumbs up or anything in the chat or anything. Yeah, lots of thumbs up. Now, a very cool thing is just looking at variables, getting idea of the variables, right? So what is the EDA? You're just exploring data, getting a feel of the data before you actually analyze it or do any processing or any modeling on it. Just get a feel of the data itself, right? So, for example, the variable. So this is the sepal length. So let me actually first look at the sample data. So this is what the data set looks like, the first 10 rows. So we have sepal length. So the columns are sepal length, sepal width, petal width, right? So different parts of the flower, just the length and the width, and then also class them, right? So there's 3 classes or 3 types of flowers and the different lengths and widths for part of each of the flower, right? Quite a simple data set to work with. It's been around for many years. I'm sure most people have come across iris data set. All right, so these are the columns that we're working with. And now we can look at the distribution of each column, right? So this is sepal length, sepal width, so quite nicely distributed. Petal length, I think this is more like bimodal, right? Those 2 probably bimodal. And then the class, right? So very nice just to get an idea of the columns that you're working with and how it's distributed. And you get some whole stats like minimum, maximum, and all these things. Interactions as well. So just comparing petal width and sepal length. So I did a pair plot using Seaborn. I added that lower down. You see it kind of displays it a bit better than this, but you can, use this as well, just comparing sepal length and petal width. Again, this is an EDA. You're just getting a feel of the data itself. I'll look at the interactions lower down. Okay, you can see the correlation, the heat map. You can see which ones are, highly correlated. So if you go to tables, it's a bit easier to see. Like you can see the I don't know, like the petal length and petal width. They're highly correlated, positively correlated, and a whole bunch of other values just to get an idea of how correlated the different values are. Missing values. Also get the matrix of that too. Not useful for this data set. And then duplicate rows, if you may want to remove it, if you can. And then this is the pair plot. So this is the one kind of graph they don't really do very well. So that's why I added myself. But you can still add it to the report, so you can add any kind of figures and graphs you want to the report. Yeah, so we can see there's a clear separation, for example, over here between the 3 classes based on the petal length and width. And the blue one, the iris setosa, is easily separable from the other classes, based on all the features, right? So I think this is quite a better representation than the other graphs that they show. Okay, so again, this is just to get an idea of the data we're going to work with. So we're going to work with the iris dataset and just a way to represent it. So we learned about this library called profile report, which I will share the link for. Yes. So yeah. So again, what we did was just a quick EDA just to kind of get a feel of how we're going to work, the environment we're going to work. Again, I was using Spider and an iris dataset, a bit of feel of the data now that we're going to work with, and we learn about pandas. That's pretty much the EDA I wanted to focus on. I can't do that in this space. Okay, so now we're gonna look at pandas. And before I carry on, just want to see what the feedback is on the questions or comments. Feel free to put in the chat. Got 100 more people messaging, responded. So okay, so 60 people from Python, about 20 on R. Again, it's familiarity with pandas. So most people aren't familiar with pandas, which is going to be a problem. I'm sure you're already lost, but we'll see how far we can go. And then Nima, I'm not sure what you mean. Yeah, we're going to cover the fundamentals of pandas, but it's not for beginners. I mean, I'm assuming most of the concepts of pandas already. It's just a bit of a refresher, right? So I actually wanted to just share that link for the profiling report because some people might find it useful. This is the one, yeah. So I will discuss how to install it, but I'll just put it here in any case. The profiling report. Is it possible to show the form? Show the form of statistics. I'm not sure what you mean, Asif. Just explain a bit more. But in any case, you can put your questions in the chat. Let's carry on. So pandas part 1, right? So pandas actually comes from the two words panel data, which are econometrics term for datasets. It's been around for many years, I think 2006 or 2008, somewhere around there. So it's been around for quite a while, and it's quite important to know that Python, as you are aware of, has its limitations, right? Then as a community, since the open source as a community has grown, they've developed their own libraries that could improve and make things automate certain processes, right? So then we had NumPy or NumPy. Which is a great tool for computational science applications. If you know Python, obviously, you have lists and dictionaries and whatnot, but the array structure and element-wise computation is very difficult. So NumPy kind of implemented an easy way to do that, and it's very fast and efficient. Also written has the backend, or how it's written, is actually in C. It's just what you call a Python wrapper to make it easy to use. But so NumPy, revolutionized how we can quickly, do computational calculations and whatnot. Interestingly, Pandas is actually developed on top of a NumPy. So you actually see the data structures and whatnot when you do the type, which I will show you. It's actually based on NumPy, like the ND array. You'll see it actually as a type, like for a series, for example, getting a column is actually an ND array. So it's actually built on top of, forms part of Pandas. So then obviously Pandas also has its has SciPy and Matplotlib kind of all combined. So what we're going to look at now is just a bit of a foundational aspect of Pandas. Again, we're not doing a sound for beginners. I mean, the concepts you might be aware of, but I'm just going to discuss a few concepts which are important to know about the fundamentals of Python. We're going to look at data structures and some functionality, and then pandas profiling. So how I showed you, what I showed you with the iris dataset, I'm going to show you how to do as well. Okay, so yes, so that is that for okay. Let's move my screen a little bit. So this is the iris dataset. Well, so this is the Python file. So there is also a Jupyter notebook on GitHub. You can use that does the same thing. You can download it and use it. And then, but the actual lesson we're going to focus on now is in part 1. Okay. All right. So we're going to look at the basics of, well, sort of the fundamentals of pandas, and that looks at typically what you're going to be doing is you're going to be reading some type of data, some type of data set. So in this case, we're going to look at a CSV file. Later in the course, we'll look at different types of files, but just to make things easier, we're just going to look at a CSV file. You can obviously create your own data frames in various ways. I'll show that a little bit later on. But for now, we're just going to be working with this CSV based on the iris dataset. Okay, so again, this is a Spider environment. And what I commented out here is, if you want to read from a website, you can quite easy with the read CSV, but it takes a few seconds longer. So I just downloaded it and I'm reading it from a local directory. So this is my Spider project, where all my files are in. So it's always good to create a project if you're going to work with files continuously. It creates stores an environment and your and how you set it up and all the files you're working with. It keeps it. So it's important to always create a project. So in Spider, you can just say new project. That, like VS Code and PyCharm, they have some as well. All right, so what I'm doing here, I'm just reading in a Pandas data frame. So what is the Pandas data frame? It's pretty much a table like in Excel. You'll see it shortly when I run this file. So if I run this file, I want to see what this data frame looks like. So again, I'm reading in the file locally. That's why it's just iris.csv, and I'm just renaming the column names, because if you look at the CSV, there aren't actually headers. That's why I'm naming it, and that's why header is none. So if you go to Variable Explorer, and this is the one awesome feature of Spider that you don't get really well supported in other IDEs, is this Variable Explorer, where you can actually instantly see all the variables and data you're working with, just like in Excel, for example. So my data frame is df, so let's have a look at it. And yeah, so this is the data frame or the data, that with the different names. So you can have a look at it. This is just some other fields I added later. But these are the if you want to have a look at it or even change values, you can if I want. So that's why I prefer Spider, because it has a Variable Explorer. I like that. You can see all the variables changing as you're coding. Okay, so just a bit of fundamentals. So if you maybe want to access a specific column, you can do that. If I run this, for example, if you want to run a single line in Spider, first run everything. So it stores it, loads the data into memory, and then you can run a single line. For example, if I do that, and then I should have to, it just stores it. I don't even need to do that actually. Let me do it like that. Yeah. So if I run this single line, that's how I can access a single row, right? That's if I want to just access that single column, I'll just reference the DataFrame df, and then quotes C for links. There are other ways to do it as well, which I'll explain a bit later. But this is how you reference a column if you just want to work with a simple column or filter it out, right? So this is quite basic. If you want to access the first value, for example, you can access it just like you do with lists or dictionaries. I go into a bit more depth but later about how to do like indexing and slicing. But this again should be quite familiar, nothing new. Okay. As I mentioned before, Spider is built on top of Pandas is built on top of NumPy, so you can easily create a NumPy ND array and store it as a series. And what is a series? So a series is just a single row of data. Sorry, a single column of data, right? So a series is a single column of data. With DataFrame, is a table of data that can have many columns, right? So these are two what I should call objects that we work with when we speak of Pandas: a series, which is a single column of data, and DataFrame, which is a table of data, so multiple columns. Okay, so if you want to just create a single one series of data, you can do that with just using NumPy's random method, which just creates 5 random values. So if you run this, I have to do. Well, I can actually just look at it here as well if you want. So that creates 5 random values. Now you can also create an index. That's why I have this index value over here for that series. So I can name it. So if I go to S2, you can see I can name each of those the index for each row. This is not really useful, but if you need to use it. You can also create a series or even a dictionary even a data frame with a dictionary. So here I create a very simple dictionary, and we go to S3. You can see that it stores the values and then the index as B, A, and C. Just note if an index is passed the values in the data corresponding, the labels will be pulled out as well. So I might do an example of that a little later. Okay, so if I see what I did with S4. So what S4 is, I kind of renamed the indexes. So if I see what S4 does, you can see that the original dictionary doesn't have a D key, right? So hopefully you know what a key is. If somebody can explain to me what a key is for a dictionary, just to know that you are listening. Yeah, so somebody in chat tell me what the key is of a dictionary, but while I get that, so it doesn't have, there's no key for D in this dictionary. That's why, when I create the series, it expects a one of the rows, one of the indexes is a D. So because there is no value, then it just creates a NaN value, which is a non-value. Okay, and then if you would just want to populate a series with a whole bunch of values, you can just easily do that. If you look at what S5 does, it'll just become all 5, right? So you don't really have to have, I know this index values, I'm just naming it just for example. Again, I'm sure you should know what head does. So head just gives you the 5 the five first rows of a pandas data frame. And obviously it cuts off a little bit, it truncates it because it won't fit the full length. But again, this head feature is kind of built into that profile reporting I showed you earlier. So you don't actually, once you use profile reporting, you don't have to use like head and tail and describe and info, because it kind of does it all for you. Okay, so that was about series, and now we're going to look at the data frame. Okay, so in terms of a data frame, so you can create your own data frames. So you can, here I used I'm creating the key as the key as 1 and 2, and then the actual values. I'm creating it as a series. All right, so if you look what df2 looks like, so where's df2? There's my series. So I'm actually storing a series within a data frame. Okay. And then df3, so this was df3 here. I'm just naming the indexes, which again, you probably won't use too much, but it's just, just showing you the features, something that you should be familiar with. And df4, again, just storing the values. You can, if you want to access the index values and the columns, and that's something useful just to take note of. Okay, so what I did was df5 here. This is just using lists. So we've used a dictionary, we've used a series and NumPy array to create data frames. Here I'm just creating a list. So I'm just showing you different ways to create your own data frame. So if we look at df5, this is just two lists of numbers, right? So two lists of numbers. Here I didn't name the indexes. By default they're like 0 until n-1, the number of, or the length of the observations. Okay. Now, when you look at the, when I showed you before, when you want to access maybe one single column, we can reference the data frame. So if we just look at the data frame again, which was over here, df, we have sepal length, sepal width, temp3, and all those, right? So if we want to access that, we just reference the data frame, df, square brackets, double quotes, and then the name of the column to access it. So I run that, I get that column, right? And interestingly, as I mentioned, pandas and NumPy are related. Well, not related. Pandas is built on top of Python and uses a lot of the features. And you can actually run a lot of NumPy methods with pandas data frames. So if you get the type of this, so you'll see it's a series. And for example, if you just want to, you'll notice that how I printed this out, it has an index and then the values, right? If you just want to get the values, just say use the attribute.values, and then it becomes an array. Now, who can tell me what type of data do you think this array is? Someone in the chat could let me know what type of data type do you think that is? Well, there are floats, but speaking about the array itself. NP array. NP, yeah. All right, so let's have a look. So the type. Run that and have a look. So it's ND array, right? So just this kind of gives you an insight into that, how Python, Pandas is built on top of Python, NumPy. So again, you can access, the values like that. A nice way to sometimes access columns, for example, so specific columns, is you can access it like an attribute, for example. So if I say df, and if you use the dot operator, and again, you have many options, but you can also reference the column length if it doesn't have spaces, which you should never have spaces in your column length. So sepal, and you see it has all the column lengths for me already, instead of having to type it out like for width. And then if I want to get values, I can just type values and that pops up the values. So this method I find a bit easy to use, and trying to like remember, okay, how did I spell the column? I've got column name and see it there with quotes. So it's a bit of a mission to do it that way. So I prefer using just the column names as attributes. Just out of interest for people that know this, the terms attributes and objects and methods, what does this all refer to, right? So something in the chat, please let me know. Attributes, methods, and objects, or what does this all refer to? Okay, so that's pretty much there. Yeah, this is a different way of accessing a column of data. So if I run this, let's see what we get. And then if we run that, we're going to get a data frame. So if we use double brackets, we can actually access it as a single data frame, right? So it's not a series, it's actual data frame, just with a single column if you use square brackets. Again, I'm still asking a question. The terms attributes, methods, and objects, what does it all refer to? It's an important concept with Python in general. Yeah. And yeah, so more about features. You can obviously do multiply two different features and add it to a length. So this is what I'm doing here, is I'm accessing two lengths of data, and well, the length and the sepal width, I'm multiplying them together and I'm storing it as a new feature, as a new column of data, right? So if I run this, it won't do anything, but if you go to df, you'll see that I have a new column now with these two rows, which was sepal length and sepal width. Sepal length and sepal width multiplied together give me feature, right? So this is a way to look at that. And then another way, just to filter some of the data, for example, if I just want to check if I want to add a new column called flag, where the feature must be larger than 20. It's already ran, so you won't really see much difference. But if you look at flag, you'll see it gives you a Boolean result, right? So is it true or false? Like which ones of these are larger than 20? It'll say true, else it'll be false. Right? So this is useful for filtering your data as well. You can delete features. You can delete columns as well using DL and whatnot. You can insert specific values or change them. You can insert series as well. So this should all be familiar to you. I'm not going to worry about too much about that. So by default, columns get inserted at the end. So as you saw here, as well with feature and flag, they were added at the end. So you can also, using insert, you can, maybe move around the column to different position by using S1 just to specify, for example, where you want to move it. Correct, Pumlani. Yeah, so we're speaking about classes here and object-oriented programming. So thank you for that answer. So very useful. It's not time to cover this, but we will cover the next lessons, is using the assign method. Allows you to easily create new columns and derive existing data from other columns. So for example, let's move this side over here. So for example, if I want to create a new column called sepal ratio, I can quite easily, and how I work that out is the width divided by length. What that'll do, it'll work it out and store it in a data frame, and then using a dot operator. So you don't actually need the dot head, but it'll store it. So I'll just take it out. So we'll look at assign again. This is what assign does. It adds sepal ratio. It just creates a new column for you with that value, and then you can also maybe just show the first 5 values, and you just so the first five rows. Okay, we're almost done with this. Then I can just look at profile reporting. So training commands again. So this is might be a bit confusing if you haven't used it before, but we will look at this. The method, the query method, which is a very powerful tool to sort and filter data. So, for example, if I look at the sepal length again, let's look at my data frame. Where's my data frame? So sepal length, which is this one over here. So all I want is for all the sepal lengths that's bigger than 5. I want to filter that, and then with that value, I want to work out a new ratio with sepal width and sepal length. Right. So what we did before was this is pretty much just copy and paste it over here. But now I only want to work out this ratio. For example, let's say if I df.query, I only want to work it out for sepal length bigger than 5. That I want to work out the ratio. Again, we will cover this again. I'm just briefly discussing some concepts. Jane, difference between line 82. I'm not sure line 82 if you got that correct. Okay, so assign just has different features. I probably line 82 is correct. So assign just allows you to do a lot more features than what you did before, just by dividing them by each other. So we will look that lesson is more features that you can do with assign. All right. So here's an example actually, is using Lambda. So this is quite interesting what you can do here, which is, say if I have a data frame that has a column A, or a list of data, column B, and a list of data. What I want to do now is create a new column C. Right, in that column, what I want to do is a built-in function. That built-in function adds column A to column B, right? So now that's stored as C, right? And now I want to create another column D that adds column A with column C. And this is what you can see at the bottom over here, what it's done. If I think DFA should be there. That's not there because I haven't assigned it. So let's see if this will change it. DFA, yeah. So again, this is quite useful to know how to do. If you want to maybe want to create a new column based on other columns, you can use assign and a built-in Lambda function. So what I did, I added column A and column B and called it column C. And then for column D, this one over here, it's going to be A plus C gives me D. And just note that C wasn't there before. but it stored it in memory for you. So it just makes your life a lot easier. Okay, so that's about that. And then index selection. Okay, so this is just if you want to, using the method lock and ilock, so it can access certain values by label, or it can by integer. I'm not going to discuss this; it's quite straightforward, and it can do transpose. So these are some really basic functionality of pandas, which you should know about. Again, this course is catered for those that are familiar with pandas. So most of this stuff should be familiar to you. I just wanted to rehash a few things and look at the fundamentals. All right. So the last thing for this lesson, we have only lecture for 5 minutes left, is to look at the profiling, how I got the profile report to work. So again, you're going to have to install profile report. So you can go to the site here. You can go to the site, and then I think it's located. Where is it? Over there. So if you use Anaconda or pip, you can just say pip pandas profiling, and then you can install it. And then when you use it, you'll just use this is what you'll import it as. And then if you, for example, create a generic data frame, it can be whatever you want. Doesn't make a difference. How you actually create the report is you have to use the method or the function profile report, and then you input your data frame and then a title for it, for example. And then what you need to do is you have to submit it or create it as an HTML, right? So this is actually all you need to do to create the report, right? But I added a bit more features where I automatically open it with Firefox. So I use a Python sub process just to open it automatically. So how this works is I just get the directory where I'm currently at, the file name, which is HTML file name. I join the path and the file name and the directory. I specify where Firefox is located, and then I just run it here. So let's just run this and see what we get. It's busy running at the bottom. Report should pop up. All right. So here's a report for you already. This is random data, so doesn't really make sense. That doesn't make too much sense. Well, it's just random data, so I won't go over it that much. But yes, so that's profile reporting. I can go over that a bit more next week if you want more example. Jane, so it's not limited to Firefox. You can use any browser, Chrome or Edge or whatnot, but I highly recommend it. It just makes your life a lot easier. And I think that is my time up. I'm a minute, about 30 seconds to go. But I think that's all I wanted to cover for today. Again, just look at the fundamentals and just to look at some things to look forward to for next week.
Yeah, Binjamin, thank you so much. That was really an impressive start in the mini school. Thank you very much. And you can see that you got lots of compliments and thank yous and thumbs up and claps. That was really nice. And also, well done for answering questions in the chat, in the Q&A, all on the fly. That was really very impressive. Well done. It's very impressive.
And just one last thing, some useful resources to look at. DataCamp is a really great resource to learn about data science and pandas.
Yeah.
And then Kaggle towards data science. These are ones I always reference and look at. So have a look at it.
Excellent. Thank you very much. And we are recording the lecture, so we will post it on our website and on the YouTube channel, so you will be able to watch it again. And Binjamin kindly shared the GitHub repository, so you can download everything and play over the long Easter weekend, so that on next week, Wednesday, we will be back here for lecture number 2. So again, thank you very much, Binjamin, for the nice lecture. Thank you very much to all the participants. It was really very nice to see so many of you taking part. I saw someone ask if it is possible still to register. Of course, if you know other colleagues that would like to join us next week, please do so. And they are welcome to watch the lecture number 1 offline on YouTube. And otherwise, I wish you all the best for the long weekend. And I will see you next week. Thank you very much, everyone. Thank you. Thank you very much, Binjamin. It was really nice. Thank you.
Thank you.